Leetcode practice question. In this video, two goals. The first goal is try to find the solution and do some coding work. And the second goal, which is different from other channels, it is we are going to see how we should behave in a real interview. So let's see how to do it. So remember, in a real interview, the first step is always try to fully understand the problem, and if there is anything unclear, please bring up the question, and at the same time think about some edge cases. So let's see. For minimum cost to connect sticks. So you have some number of sticks with positive integer lengths. These lengths are given as an array stakes, where stake I is the length of I stake. So you can connect any two stakes of length x and y into one stake by paying a cost of x plus 1. Okay, so you must connect all the stakes until there is only one stake remaining. Return the minimum cost of connecting all the given stakes into one stake in this way. Alright, so let's see the example. We have 2, 3, 4, and 3. First of all, we combine 2 and 3, then we combine 4 and 5. Okay, it makes sense. Okay, so let's see the constraints. It says that the stakes would be, the number of stakes is between 1 to 10k, and also each stake has a length of 1 to 10k as well. Alright, so how to solve this problem? After we fully understand the problem, it's time for us to do some thinking to find a solution. So I don't see some very clear edge cases, but I would say if the length of the stake is smaller than 2, then you just need to return 0. Other than that, it's just a regular algorithm stuff. So let's see how to solve this problem. So this one, it actually remembers me something called a Hoffman tree which is in our task book. So Hoffman tree, if you don't know it, please just do a Google search to see what it is. So the idea to solve this problem would be something like every time we pick the two numbers within the array, two smallest numbers within the array, and then get the sum, and then insert the sum into the array. And the next time, similar stuff we are going to pick. So okay, so let me just write it down. First of all, pick two smallest numbers, and let's say num1 and num2. And step 2 is to insert num1 and num2 plus num2 into the array. And 3 is to repeat step 1. So in this case, we are going to finally find the minimum cost to construct the Hoffman tree, and for this one we are going to find the minimum cost to connect sticks. So having said that, the runtime is going to be a log n. So n is the length of the array. So what is n log n? Because we are going to use a min heap here to find the smallest two numbers. So the min heap is going to take log n time to get the minimum number. So that's pretty much it about the solution. So the next step for us to do is to do some coding work. So for coding, we care about the correctness of the code, the readability of the code, and of course the speed is a concern. So having said that, let's do some coding work. So first of all, some edge case tracking. If stakes.length is smaller than 2, then we are just going to return 0. Otherwise, we are going to have a priority queue. Okay, so the priority queue will be some integers. Let's say this PQ. Let's call it min heap though. New priority queue. QEUE. Okay. All right. So we are going to first insert pretty much everything into the heaps stakes. So min heap dot add the stake, and then every time when the min heap, the min heap dot size is smaller than is larger than 1, so we are going to do int stake 1 is equal to min heap dot pool, and stake 2 is equal to min heap dot pool, and also at the same time we need to define the cost. Let's say define as min cost as 0. So we are going to say main cost is equal to stake plus equal to or we just define a local variable. Let's say cost is equal to stake 1 plus stake 2, and then we are going to have main cost is equal to plus equal to cost, and we are going to have let's call it connected stake. So this will be the main cost plus equal to connected stake, and then we are going to have min heap dot add the connected stake, and then finally we are just going to return min heap dot pool. So that's it for the code. Let's see, let's do some testing here. So for testing, we care about we essentially we need to do some sanity check to check the logic to see if it is correct, and then after that we are going to set up some different test cases to test different branches to make sure we have good enough test coverage. So let's say we go through this one, which is 2, 4, 3. So first of all, we put everything into the main heap. For the first time, we pop 2 and 3, we connected as 5, and then we have min cost as 5, and we insert the 5 into the main heap. Now we have 4 and 5 in the main heap, and then we are going to have okay, so the main cost this time, so first time we connect 2 and 3, so we have the cost as 5, and the next time we have the 5 and 4, the connected cost is equal to 9, so we have the main cost as equal to, okay, so it should be actually we return the main cost. So 4 and 5, which is 9, so now we have main cost as 5 plus 9, which is 14. So I think it should work. Let's give it a shot. Alright, so let's do a submission. Okay, so everything works now. So that's it for this coding question. If you have any question about the solution or about the puzzle, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.